So today's video is going to go over functions and their inverses. So we've learned earlier that inverses of an operation or functions undoes that operation or function. So for example, subtraction is the inverse of addition, logarithms are the inverse of exponential functions. We're going to talk about that soon. And then square roots are the inverse of squared functions. So graphically, the inverse of a function is that function reflected across the line y is equal to x. And that is the line in a graph that goes like this, right? The inverse may or may not be a function, however. So remember that the vertical line test can determine if a relation is a function, and the horizontal line test will determine if the inverse of the function is also a function. So the horizontal line test determines if a function is a one-to-one. That means for every x in the domain of the function, there's exactly one corresponding y value. So basically, you cannot have two y values for one x value. So a function must be one-to-one for its inverse to be a function, okay? So a horizontal line test. So if any horizontal line passes through more than one point on the graph of a relation, then the inverse relation is not a function. So basically, like here, if I draw any of these horizontal lines, this inverse is a function because those horizontal lines that I drew do not pass through that curved graph more than once, okay? Whereas over here, if I start drawing some horizontal lines, you can see multiple places where I draw horizontal lines and it intersects the graph at 2 points. Y'all see that? So that's why horizontal lines, if I can draw a horizontal line across the graph and it intersects the graph at more than 1 point, then it's not a function. So using the horizontal line test on the graphs below, determine if the inverse of each relation is a function. So I could literally draw a horizontal line anywhere here and it does not impact it more than once. So this is yes, this is a function, okay? Now this one right there, notice it intersects at 2 places, there and there. And if I drew one down here, it actually intersects at 4 places. 1, 2, 3, 4. So this is definitely going to be a no, okay? The next one, doesn't matter where I draw a line. Any place I draw the line, it only intersects it once, so this is a yes. And again, this last one over here, if I draw a horizontal line there, I get that it intersects it twice. You'll see it. And obviously, if I drew it multiple other places, it would also intersect it twice. So again, this is no, because that horizontal does not pass the horizontal line test. So for this next one, it says, since the inverse is a reflection of the original function over the line y equals x, you can determine the graph of a function's inverse by exchanging the domain and the range of the function. So what we're going to do over here for this first one, number 1, is that's exactly what we're going to do. So we're going to take this point right here, which is negative 4, 3, negative 4, 3, and then we're going to take this point, negative 2, 2. And we're going to keep going, and we're going to do 0, negative 2. And then our last one here is going to be, what is that? 3, negative 3. Okay, so those are our original values of our graph, right? So now what we're going to do is we're going to flip those. So we're going to make the y the x and the x the y. So we're going to do 3, negative 4, and then 2, negative 2, negative 2, 0, and negative 3, 3. So now we're going to plot those points. 3, negative 4 is down here. And then we have 2, negative 2 right there. So I'm going to go ahead and draw that line because it's a straight line. And then 2, 0, negative 2, 0. So that's negative 2, 0 right there. So I'm going to draw a line like this to there. And then I got one more, negative 3, 3. So that one's up here. So now I'm going to draw that line, okay? So now what you should notice is that this is a reflection of the line y equals x, which would be right there. And it is. You notice that? It is a perfect reflection over the line y equals x. And that's one of the ways that we can test to see if this actually is an inverse, okay? So now what I'm going to do for this next one is I'm going to plug some points in there, okay? So I'm going to put in negative 2. So I'm going to do negative 2 plus 2, that's 0. The square root of 0 is 0, and 0 from plus 1 is what? 1. Okay? Then I put negative 1 in there. When I do negative 1 plus 2, that's 1. The square root of 1 is 1, and that would be a negative 1 because we would multiply the negative times it. So that would be -1, 0, which makes sense, right? Okay, then I'm going to put the number 2 in there because 2 plus 2 is 4. What's the square root of 4? 2. And then it's going to be a -2 plus 1. So that's going to be 2, -1. And then I'm going to put a 7 in here, y'all, because 7 plus 2 is 9, and the square root of 9 is 3. So that's going to be -3 plus 1. So that's going to be -2. So this is going to be 7, -2, okay? So now I'm going to go ahead and plot those points. So I got -2, 1 right there. And that's the starting point of our graph, and we should recognize that because of h and k, right? And then we've got -1, 0 right there. And then we've got 2, -1 right there. And then the other point I plotted was 7, -2 right there. So that's enough for me to go ahead and graph it, okay? And that's what I'm going to do, okay? So now we're going to do the inverse of that, and we're going to flip the x and the y. So this is going to be 1 because that was my y, and this is going to be -2. And then this is going to be 0 and -1 and -1 and 2 and -2 and 7. Okay, now we're going to plot this one. So 1, -2 is down here, right there. And then we got 0, -1, which is right there. Sorry, no, not right there. 0, -1 is right there. Then we got -1, 2 right there. And then we've got -2, 7. -2, 7 is right there. Okay, so this is what our graph looks like here. And notice again that this is what? A reflection over that line, y equals x, okay? All right, so the U try. Go ahead and do these two and then come back to me when you're done. And I would suggest you make a table of some points down here on the left and then flip them, okay? So what I'm going to do here is I'm going to pick some points. So that point right there is what? 1, 3, and then we got, what is that point right there? That's -1, 1. And then let's pull one down here. So what is this? This would be like -2.5 and 3, -3. Okay, so what we want to do now is go ahead and plot that, or actually do that. We're going to do the inverse of that, okay? So I'm going to actually flip that. So this is now going to be 3, 1, 1, -1, and -3, -2.5. Okay, so let's go ahead and plot those points. 3, 1 right there, and then we've got 1, -1 right there, and then we've got -3, -2.5, which would be about there, right? So this is what our graph is going to look like. Yep, and then once again, look at that. It looks like a what? A reflection over that y equals x, okay? All right, so now on this one, I'm just going to plug some points in there, y'all. So I'm going to plug in, let's see, what do we want to do? Let's do -3. So if we do -3, that would be -3 squared. That's 9 minus 1 would be 8. And then I'm going to do -2. So that would be 4 minus 1. So that's going to be 3. And then let's just go ahead and do 0. And 0 minus 1 would be -1. And then go 2 again. That's going to be 3. And 3 and 8. Okay, I'm just going to do something so I get a good enough picture of the graph. All right, so on this one, let's go ahead and plot this blue graph. So that's going to be -3, 8 right there. And then we got -2, 3 right there. Then we got 0, -1 there. And then 2, 3 again there. And 3, 8. 3, 8. So question, based on what we just did, is this going to end up creating, now the first one, the U try, was what? A function, yes, because why? We could do our horizontal test on our first one and it never intersected it more than once. What about this one though? Now if we do our horizontal test, is our inverse function going to be a function? No, okay? And that's because it doesn't pass a horizontal test. That doesn't, however, mean that we can't find the inverse function, okay? So we're going to flip these again, 8, -3, 3, negative 2, negative 1, 0, 3, 2, and 8, 3, okay? So let's go ahead and plot this one now. 8, negative 3 is here. And then we got 3, negative 2, negative 1, 0 is right there. Then we've got 3, 2 there, and then we've got 8, 3 there, okay? So notice this thing is turning, isn't it, okay? So once again, you should be able to see that this is definitely reflecting, but this one right here didn't pass the test, so the inverse is not going to be a function. And let's go back again and look at these two. What about these? Horizontal test, yes. Horizontal test, yes. So both of these are going to be, the inverses are going to be functions, okay? All right, so now, algebraically, you can find the equation for the inverse of the function by switching the x and y and solving for y. So since x and y have been switched, the domain of the function will be now the range of its inverse and vice versa. So we're going to find the inverses of the following functions, and we're going to determine its function and its state, the domain, and range, okay? So let me see if I can move this thing. It's not moving. So it's supposed to say domain and range. There you go. So, all right. So first we're going to rewrite this equation. And we're going to put a y where the f of x was. So we're going to say y is equal to 1/2 x plus 2 squared. Now we're going to switch the x and y. Important, okay? So I'm going to say x is here, and that's equal to my 1/2 y plus 2, okay? And now this is still being squared, okay? So what must we do first? So aren't we going to take the square root of both sides? So when we do that, we're going to have plus or minus the square root of x. And that's still going to be equal to, because remember, we had to take square root of both sides to get rid of that square. 1/2, and there's our y, and we got our plus 2, okay? So then we're going to simplify the right side, okay? So that means we're going to subtract the 2 from what we already have. So we could do this one of two ways. We could leave the plus or minus in front, or we could put the minus 2 in front. It doesn't really matter. But I'm going to leave it like it is. So I'm going to do plus or minus the square root of x. And then I'm going to do what? Subtract 2 from that, and that's still equal to 1/2 times our y. Okay, so how do I get rid of 1/2? Yes, multiply both sides by 2. So my next one is going to be 2 times plus or minus the square root of x minus 2 equals y. So that is our inverse function. So I'm going to rewrite it here. Y is equal to 2 times plus or minus the square root of x minus 2, okay? Now, in our original function, were there any domain restrictions? No. But what about the range? So if I square anything, what kind of number am I always going to get? Yes, a positive number. So if you notice here, the range of the f of x is y such that y is greater than 0, and the domain is all real numbers. So what's going to happen here is these are going to flip, okay? So now we're going to say our domain restriction is going to be x such that x is greater than or equal to 0. And then what about our range? It's going to be all real numbers, right? So they're just going to flip, okay? So that's what you need to keep in mind when you're given the domain range of the original function. The domain and range are going to flip for the inverse. So down here it says because of the plus or minus symbol, there can be two values for one value. So the inverse is not a function, right? And the notation f to the negative 1 cannot be used. This is really important, okay? So just pay attention to that when you guys are doing it, all right? Now, this says find the inverse of each function, determine the inverse if the inverse is a function, and then the domain and range. Okay, so here again, so on this original function, let's just think about this. Our domain, because it's a cube root, is going to be all real numbers, and our range is going to be all real numbers. So that means that's not going to change when we create the inverse. So this is going to be y is equal to x to the third minus 2. That's our original equation. We're just changing the f of x to a y. So now we're going to flip these. X equals y to the third minus 2. So what am I going to do? Add 2 to both sides, right? So x plus 2 equals, let me go back and make that still my x in red. So x plus 2 equals what now? Our y to the third, right? So how do we get rid of a third power? We're going to take the cube root, right? So we're going to take the cube root of both sides. So this is going to now be the cube root of x plus 2. And that's going to be equal to just our y, right? So that's our inverse right there, okay? Now, what do we know about cube root functions? They too have a domain and a range, domain of all real numbers, right? And a range of all real numbers, okay? So here again, cube root, this domain, all real numbers, range, all real numbers, right, y'all? Okay? Just do 2 sides of the R and then the curves, okay? So here again, I'm going to rewrite this as y equals the cube root of x plus 1. So now I'm going to flip-flop my x and y's. This can be my x. It equals, again, the cube root of what? Y plus 1, okay? So now what are we going to do to get rid of a cube root? We're going to cube both sides, right? So let's go ahead and do that. We're going to cube this and cube this. So now this is x to the third equals y plus 1, right? How do we get rid of a plus 1? We subtract it, yes. So this is going to be x to the third minus 1, and that's what equals our what? Our y, yes. So that is our inverse function there. And again, our domain and our range are going to be all real numbers and all real numbers. Okay? All right, so let's do, you guys do the next U tries. And this one's a little challenging, number 4, y'all. So just go ahead and do these 2 U tries and then come back to me when you're done. Okay, so let's go ahead and I'll just do this in color. Y equals 2 times x plus 1 squared. So I'm going to rewrite that. X equals 2 times y plus 1 squared. So what do I do first? Divide everything by 2, right? So that's going to be x over 2 equals y plus 1 squared. How do I get rid of a square? We square root it, right? So that's going to give us the square root of x over 2 equals y plus 1. How do we get rid of the plus 1? You got it. We're going to subtract it, right? So this is going to be the square root of x over 2 minus 1 equals y. Okay, so here's my question. So we originally had our domain here is all real numbers, right? So once again, when we square any number, what does it become? Positive, right? So our x values are going to be, or let's just say our domain. Let's do it that way. Our domain is going to be all real numbers, right? But what about our range? Isn't our range going to be y is going to be greater than or equal to 0? It is, okay? So because any number we put in there is going to be positive, okay? So even if we put 0 in there, well, actually, let me think that through. If we put -1, yeah, it's all going to be, no matter what number we put in there, it's going to be positive, y'all. Because if we put -1 in there, it's going to be 0 times 2, 0. Yes, that's going to be basically as small as it's going to get because every other number is going to end up being squared. It's going to be bigger than that, okay? So that means down here, our domain and range is what? So our domain and range, remember they're going to flip, okay? So our domain was all real numbers. So now our range is going to be all real numbers, right? And then what is our x value is going to be? X is going to be greater than or equal to what? 0, right? Because again, if we do have anything less than 0 in there, aren't we going to get a negative number? And that would not be a real number, okay? So let's talk about domain and range for this function right here, okay? So remember, we have our h here and our k here, right? So our domain is going to be, x is going to be, now look, this graph is going to go down here like this, right? Because it's a reflection over the x-axis. So the domain is going to be what? Greater than or equal to 4. Our range is going to be, y is going to be what? Less than or equal to 3. Right? Okay, now that's really important, y'all, because it's going to affect our domain and range of our final answer. So once again, let's work this. So this is y equals negative square root of x minus 4 plus 3. So we're going to flop the x and y. So this is now x equals negative square root of x minus 4. Sorry, y minus 4. See, I got to watch that. Y minus 4 plus 3. So now what do I do first? Let's subtract that 3. So that's going to be x minus 3 equals negative square root of y minus 4. So let's go ahead and divide both sides by a negative 1, or multiply both sides by a negative 1. So that would give me a negative x plus 3 equals what? Square root of y minus 4. So what are we going to do now? Are we going to square both sides? So that's going to give me x squared minus 6x plus 9 equals y minus 4. And then we're going to go ahead and move that 4 over to the other side by adding it. So my inverse is going to be x squared minus 6x plus 13 equals 0. Okay? So, or y. Sorry. I don't know. Sorry. I said 0, y'all. Y. Okay. So that's our inverse right there. Okay? That's our inverse right there. Now, what can we say about our domain and range, though? Our domain is what? X now is less than or equal to 3, and our range, y, is what? Greater than or equal to 4, okay? So just remember, they just flip. That's all they do for our domain and range, okay? Very important. All right, now here's an application problem. It says the number of times that a cricket chirps per minute can be found by using the function n of f is equal to 4f minus 160, where f is the temperature in degrees Fahrenheit. It says find and interpret the inverse. So to do this, all we're going to do is solve for f, basically. So I'm going to write n equals 4f minus 160, okay? So now I'm going to subtract the 160. So n equals, so let's just do it this way. So n plus 160 equals 4f, and then we're going to just divide both sides by 4, right? So if I want f, f is equal to n plus 160 divided by 4. All right, now, what does this mean? So originally we had the chirps based on the temperature, right? Now, now we have the temperature. This is now the temperature based on the chirps, okay? Per minute. That's what it is. So then it says, what is the temperature when the cricket is chirping 60 times a minute? So we want to find the temperature, right? So that's our Fahrenheit, okay? So we're going to use the formula we just created, right? So we're going to go 60 plus 160 divided by 4. So that's going to be 220 divided by 4. So that's actually 55. So that means the temperature is 55 degrees Fahrenheit when a cricket is chirping 60 times a minute. So this next one says, how many times will the cricket chirp in 1 minute at a temperature of 80 degrees Fahrenheit? So this is basically our first formula, right? So we want to find out the number of times he chirps. So we're going to do 4 times 80, and then we're going to subtract 160, right? So that's going to be 320 minus 160, so that's going to be 160 chirps per minute. Okay, now based on this, let's see if you guys can do the application you try. It says the managers of a pizza restaurant have found out that the function t of d equals 20 plus 2.5d. It models the length of time in minutes after a pizza is ordered for a pizza to be delivered a distance of d miles. So what does that mean? That means that I've got d is equal to 20 plus, no, actually let's say time. That's actually time, sorry. Time is equal to 20 plus 2.5d. So if we want to do the inverse of that, what are we going to do? We're going to subtract that 20. So it's going to be t minus 20 equals 2.5D. So then we're just going to divide that by 2.5, right? And that's going to give us our D. So our formula is distance is equal to the time minus 20 over 2.5. And what does this tell us? Okay, so this one says the original one was our time based on distance, and so this is now distance, right? Aren't we solving for distance, y'all? So what are we going to write here? We're going to say the explanation is this is distance based on the time. Okay? All right, so it says how far away can a customer live? So it's basically asking us for the distance. And still get a pizza within 30 minutes of placing the order, okay? So that means I'm going to solve for D this time. So I'm going to take the 30 minus the 20 and then divide that by 2.5. So that's going to give me 10 divided by 2.5. So that gives me 4, and that's 4 miles.